Hello everybody, welcome to this new lesson. A lesson we are going to dedicate to the use of LEDs and more specifically the use of NeoPixel. NeoPixel is a special kind of LED which is not called NeoPixel. NeoPixel is like the name that it was given from a producer of NeoPixel called Adafruit. The name of NeoPixel is WS2812. Whenever you look for WS2812 or 11 or 13, like the one we are using, which is the trade-off of using these LEDs versus the fact of using normal LEDs you could buy from the very normal hardware store. Well, the very big difference is the fact that these LEDs, they have a chip inside and they can communicate to one another. So they need a microcontroller to work. So you need an Arduino in order to control these LEDs. There are some other solution. I mean, there are some controllers built for these LEDs. In order to have them working, we have them in this special form factor, which is this LED ring, but you can even, with the same code we're going to use, you can even take a 5 meters strip, very dense one. Some of them are meant to be in the water, they are IP67 or whatever, and you can control it as many as you want. The only thing you have to take in account, of course, is the longer the strip, the higher the necessity of having an external power supply, because Arduino is now powering this 16 for me, 20 for you LEDs mounted on this ring. And if you go with total brightness, total white, that pin of Arduino may be not enough to power all those LEDs. If you take a long strip, you definitely need to have an external power supply. In order to work with these LEDs, we need to import a library, which is called NeoPixel. Obviously, I have it already installed. I can update it. Okay, once you have it installed, you can go in example. It's called Adafruit_NeoPixel, and we can do the strand text example. I have hooked up the LEDs on pin number 3. You have the library import, and then there is this code which checks whether the board we're using is AVR or ARM. I mean, you can pretend these lines are not there, they're not important. And then there is the declaration of the strip, which has, I mean, the Adafruit NeoPixel function is satisfied by 3 values, 3 parameters. The first one is the number of pixels. The second one is the pin we have used the Arduino to connect to the, in this case, in the LED ring, in most cases, the strip itself. And then the third parameter is the more complex one, and it's based on the kind of strip you are using. So we'll leave like that, but this library works with many different NeoPixel strip, and you'll be asked to change to other parameters in order to make it work. This one simply changed the RGB or RGBW, which is white. This one is the frequency. Let's see if this works. It should work. Let's upload this and go through the code and see what happens. You can easily do this example and check yourself. So in the setup, we are again checking the hardware. This is a AVR at T5 is a different hour from Ardor from ours. And yeah, the important thing is like start the strip, set its brightness to 255 and initialize them as off, because at this point all LEDs are off. And then we call several functions, we're going to see a bunch of them, that are using several methods of this library. So how does this work? Let's see which is the documentation, which in this case is quite good. The documentation of using this NeoPixel library. Okay, so you need to include it, you need to declare the pin, the number of LEDs, the declaration and the declaration of the strip method, of the strip function, um, the declaration of the strip, and then there is this strip set pixel color that allows us to control the behavior of each LED. So in this case, is N is whichever LED from 0 to 19. If you want, suppose you want to make one LED blink, okay? I want LED on position 1 to blink. So before we step in all this funny library, funny functions, well, I'm going to do I'm going to say I want pin number 6 to be red for 100 microseconds and then turn black. So I want the pin number 6 to be red, green, and blue. So this is called pick the pin, the LED number 6, and paint it red, and wait 100 microseconds, and then make it black. So this is not going to work. We have to remember tell the strip to show. Whenever we want this code, this information to be sent to the LED, we have to tell him, send it. Okay. Before going and see the function that are made in this example, of course, I could nest this into a for loop and say, wait, we have E, which is equal to 0, E is less than 16, which is my number. You can put 20 here if you have a 20. You have a 20 LED ring. I have a 16 one, so I want to go through all the ring and go back. So I'm going to keep that 16. I want to increase by 1. So what I'm going to do here is, instead of naming a specific LED, I'm going to cycle through all LEDs. So what's going to happen is going to light the LED and switch it off. Everyone, hopefully, knows. Let's see. Okay, so we could also, playing with this number, we can say, hey, the one before, I want it to be slightly less red, and I want him to switch off here. Okay, you cannot see it, or it's like not really evident, but the big picture is We have an LED, which is the one closer to the one we were controlling, the one before, that has a different color. So we are able now to control all LEDs based on little calculation we do on this incremental for loop. This is the basic concept of the library. And they use the library, the use that people do with this library. So suppose now I want to control the color in a different way. You have plenty of ways to control the color. This one is the most common. So the strip color, instead of specifying, is, I mean, it's the same, but it's more used. So I think this, let's decrease it a little bit. This is not going to change anything in the behavior. Well, the second LED is going to be less red. There is a mistake. Oh yeah, there is a mistake. Sorry, Arduino. Okay. So what happens now? We could take this for loop and go outside of the loop function, like here, and write void my LED function. Okay. So whenever I call my LED function inside of the loop, my LED function is going to, this part, this line number 13 is going to teleport itself here and run the very same code. So nothing is going to change. The powerful thing of the function is that we can pass parameters here. And for example, we could pass the color. The color, as you can see, it's a strange type. It has to be this, which is a very big integer. We call it C. And the color we want to pass is the color when they turn on, of course, not when they turn off. We have two colors here, so maybe we have to So this means that whenever I call my LED function, I have to specify inside of here two colors, the one of the first LED and the one of the second LED. We can even add another function, which is the speed. So if I call my function and I want my first red LED, I can my first LED red, I can like pass this. The second LED, I want it to be green. And I want to be super quick, like 50 microseconds. Okay, so we have managed to create a function, specify special parameters we can pass through the function, and call it. All this story I told you, why? Well, first of all, functions are really, really important encoding in Arduino to put bigger parts of code you have in the loop somewhere else and optimize them. Also because, as you can see, now I can call another function, which could be, I'm using the very same function to specify different approaches. Different instances. So what's going to happen is going to be one for loop of the first function, the second for loop for the second function, and I can like simply keep on calling them my let function with different parameters, and it's kind of working. So what they do here, I commented, I previously commented all long examples, is that they give you in this library a lot of pre-made functions. For example, this one, color wipe. Color wipe is really similar to the one I wrote. It's passing one color, one time. There is one for loop, and the for loop is simply using the setPixelColor method to control one specific LED with one specific color. Again, the weight is passed to control the speed of the color. There are many others. Some of them are quite confused, maybe to your eye. But what happens here is actually um, the color. You see, the color is a calculation is based on the increment, as we did before. Several variation of the rainbow, and theater chase, which is somehow related to the one I've just wrote. Um, Turn every third pixel, so it calculates distances between the eye and allows you to create special effects. Let's see theater chase in its wonderful. Okay, so we've seen this really big topic of LEDs, specifically WS28, 12, and 13 LEDs, which are known also as NeoPixel. We've learned how to control a specific LED, how to cycle through the length of the LEDs in order to control more colors and more LEDs. We were able to create a function that had parameters we were passing inside of the function in order to call that function whenever we wanted to, and this allowed us to see the other functions that are given as an example in the strand text example we have seen. See you in the next lesson.